Hello everyone, Mr. Schultz here for Integrated Math 2 as we delve into the volume of cones. So let's use number 1, but before we begin, make sure you wrote your first name and your last name at the top, as well as your date, as well as your period number. Alright, here we go. So before we begin, let's figure out what the height and the radius of this. The height of this cone is 12 kilometers. The radius is not 12, it is 6 kilometers. Now, let's draw this and pretend it's its original shape. If we were to draw this out, we would see that, hey, if this shape repeated all the way up without shrinking to a point, it would be a cylinder. So now the area of a cylinder is going to be pi r squared times the height. But wait, how much of the cylinder are we checking? So we can go into and create a more in-depth idea about it, but if we were to draw in the two parts that are not the cylinder or not the cone, it would be 2 out of 3 that are not the cone. So how many are the cone? 1 out of 3. Now, I don't have to do 1 times this. I could take this 1 off. It's okay. But I'm going to divide it by 3. Now, give me a second here. Alright, so now let's plug in our information. We know the volume is equal to pi times the radius squared. So that's going to be 6 kilometers squared times 12 kilometers. Now, if I use my handy-dandy calculator, I'm going to get the volume is equal to, get out your calculator, let's go. Turn it on. Pi times 6 squared times 12, and then I'm going to divide by 3. It's going to be 452.39. Once again, that's 452.39. But it's not kilometers. What are we counting? Not measurements, kilometers, no, not squares, square kilometers, but cubes, little boxes. Now, if you wanted to, you could have simplified and then had like 6 squared, 36 times 4 times pi, and you'll get the answer. Like, you can simplify, but you get to use a tool, and your tool is a calculator. All right, let's do number 4. Let's draw a line across. Let's do number 4 together. The height is equal to 19 yards, and the radius is equal to 6 yards. So I don't need to figure out what is the radius, what's the height. I already have them. But now, what I'm going to do is I'm going to write out my equation. The volume is equal to 1/3, so I'm going to divide the volume of a cylinder by 3. So it's pi r squared times the height. Well, let's do it. The volume is equal to pi times 6 yard squared times 19. Now, before you divide if you wanted to divide this 6 by 3, don't do it yet. It needs to be squared first. So it has to turn into 36 before you do anything else. But, don't worry about it. Okay, so I would get pi 36 square yards times 19 yards. And if I divide by 3, I'll get 12 times 19 times pi. Or just use a handy-dandy calculator and get your answer. which would be pi times, now I could either put 36 or I could put 6 squared times 19, and then we're going to divide by 3. I get 716.28. 716.28. Now on every single one of these, I'm rounding to not the 10th, but the 100th. So this is 716.28 yards. But wait, what are we counting? Are we counting squares? No. Are we counting just yards, like a measuring tape? No. We're counting little boxes, little cubes inside the three-dimensional object. Alright guys, go ahead and finish up this document and turn it in, and I will see you guys tomorrow. You guys have a wonderful day. Bye.